So whether you get the TI-30XS multi-view or the TI-34 multi-view calculator, or does anybody have a TI-83 or TI-84 calculator out there? TI-83 or a TI-84?
Had the TI 30XS, but I have to purchase a new one because I misplaced it.
Oh, okay.
Yeah, I have the 83.
Yeah, the 83 will work fine, no problem. The TI-30 is not really that expensive. The TI-83, 84 calculator is a lot more expensive than the TI-30 or TI-34. But if you plan on getting back on the STEM track at Mott, the science, technology, engineering, mathematics track, you may want to invest in a graphing calculator like the TI-84 calculator because you will be using it in those higher level courses, okay? But for this course, it's good enough just to have a TI-30 or a TI-34. Those are the recommended ones. All right, they're nice because they can work with fractions and mixed numbers very easily, something that even the TI-83 cannot do. All right, but the TI-83 can do pretty much anything that we're going to be doing in this course. So if you have that or the 84 model, you're welcome to use that. But like I said, the TI-34 or the TI-30 is an ideal calculator for the course. So I'll just leave it up to you what you want to do with this, okay? All right. All right, we'll be meeting Tuesday, Thursday, 12:30. Of course, obviously you have to have a reliable internet connection. Now, if you get disconnected, ladies, I'm just trying to reconnect. If I ever get disconnected, I mean, it's happened in the past. It's not infallible. Just have patience with me. All right, don't leave. I will make every attempt to reconnect. Okay, and if I absolutely cannot reconnect, I will send all of you an email via my phone. All right, indicating the problem and give you further instructions. All right, but another nice thing is that if you missed the class session, you're in luck because I am going to post the recorded lectures, all right, for every class session. And so that's a nice thing to have. It enables you to go back and slow things down and work with the lecture on your terms, all right. So I will try to have the lecture up and running after this class. Sometimes it does take me a little bit longer to get it uploaded because of my schedule demands. I do tutor online for a company, and that really takes a lot of my time up. But I try to have it the recorded lectures up and running in a reasonable amount of time. Okay. All right. Obviously, you want to come to class on a regular basis, and coming to class on time is a cordial and nice thing to do. If you are late, always come in muted. That's all that I ask. You do not have to have your camera on, ladies and gentlemen. I'm not going to have a camera on myself during these sessions. Only at the beginning of the session will I have a camera on myself for a couple of minutes. All right. Student handbook, be familiar with that there. This is the grading scale that's going to be used for this course. I've used this for years here at Mott. And, if you're on the upper edge of a grade category, unless you give me reason not to, I have no reservation other than to bump you up to the higher grade category, and I will do that. Like if you have a 92%, let's say, and an overall average after all adjustments have been made with your grade, I'll bump you up probably to the 4.0. Okay, give you a 4.0. You got to be right on the edge though, and usually having a little change with that 92%, like 92.4% or something like that helps. Okay. All right, these are going to be the weights assigned to the things that are going to, form our grade. Class activities are 5%. just every session that we meet, there will be short written class activities of which will want you to email to me by midnight of the same day of the lecture. And if you do that, ladies and gentlemen, all that I basically check is to see that, you know, that you participated in the class activity. If you did, you'll get your 100%. Okay, very easy grade to get is class activity grade. Now, if you miss a class activity, I do allow 2 drops for class activities. And because of that, class activities are not make-upable. All right, there's no make-ups on class activities. You're either here and we do them, or if you miss class, you just miss it. All right. You're allowed to miss 2 and it won't even show up on the radar though. All right, homework. Alex homework and textbook homework will be weighted at 15% of your grade. Alex quizzes, 20%, and Alex exams, 60% of your grade. And so these add up to what, 100% of your grade. All right, a non-engagement grade will be issued if you stop coming to class after today, and I have absolutely no work turned in from you after today, but you failed to drop the course, you will be issued an NE grade in all likelihood. All right, incomplete grades can be issued as long as you qualify for one. And the qualifications for an incomplete grade are at the latter end of this syllabus. Normally, I am very reluctant in giving an incomplete grade because history has shown that students very, very rarely ever follow up on them and complete them in the following semester. Okay. Again, with the email, always have Math 115 Hybrid 02 in the subject line. That expedites me knowing who you are and what section you're from, and it speeds up my service. Alex, like I said, is an important component for this course since this is an online course. You'll be doing quizzes and exams and homework on Alex. All right, to register for Alex, ladies and gentlemen, you'll need an access code that can be purchased individually if you do it through our Canvas course site. And then you can use the e-textbook for the course, or if you insist on purchasing a hard copy of the textbook, make sure it comes with the access code. It should, but make sure it does before you leave the bookstore. All right, you'll need the access code and this course code to register with Alex. It's a one-time registration. Once you're registered, you're good for the semester. Okay. There will be 4 exams. We'll look at the schedule in a second. Exams will be completed individually on Alex. You'll have 1 attempt at the exam. Exams will be due according to the due date on the schedule. Late exams will be scheduled penalized 10%. Now, I will replace 1 lowest non-zero exam score with the highest exam score that you've earned before computing final grades. Now, this is very important when you sit down to do the Alex exam, that you have something to write with, something to write on, and you have your calculator. And you can also have your lecture notes or any other notes you want by your side that'll help you remember things. And ladies and gentlemen, you need something to write with and write on, because when you go through the problems on Alex, you're going to have to work them out on paper in all likelihood. Very few problems can you do with your mind. All right, they're too involved. All right. So just be prepared when you come to that Alex exam. You should do things in a specific order as far as Alex is concerned. You should always do the Alex homework first, then the Alex quizzes, and then the Alex exam. Always do them in that order. All right, homework, quizzes, and then exam. There will be 9 quizzes on Alex. Quizzes, again, will be completed individually. You'll have 2 attempts at the quizzes, and the highest score will be recorded. If you do a lousy job on the first attempt, the second attempt is called a quick retake, which only forces you to retake the problems that you scored incorrectly on. You don't have to retake the problems that you got correct. Okay. Quizzes are due according to the due date on the schedule. Late quizzes penalized 10%. Here's a beautiful thing. I will replace 2 lowest non-zero quiz scores with your 2 highest quiz scores before computing final grades. And again, make sure you have something to write with and to write on, and have your calculator and or any other notes when you sit down to do the quiz. Homework is a very important thing in any computational course because it helps you to realize where you are with the material. I mean, if you're not getting any of the homework problems correct, ladies and gentlemen, then obviously you're not ready for a quiz or exam. If you're getting most of the problems correct, then you're probably ready for a quiz and exam. Okay. So just make sure that you always do the homework first before you try any quiz or exam on Alex. All right. Now, exam questions and quiz questions are very similar to your homework problems. For that reason, homework is critical. Another nice thing when you do your homework on Alex, if you get stumped on a problem, off to the right side, there's a button you can click on that will enable you to view a similar example. And your author will work the example out in great detail. And then you can then go back to your problem and then try to emulate that and do your problem. Okay, so that is a wonderful feature to tap into when you do your homework assignments. Now, on your quizzes and exams, you will not have that feature available, ladies and gentlemen, but on your homework, you will. So you can always look at guided solutions before you attempt your problem if you're a little bit fuzzy on how to complete it. All right. Of course, homework has due dates, just like everything else. That's on the schedule. You'll have unlimited attempts at the homework assignment, and the highest grade will be recorded up to the due date. Of course, after that, there's a 10% penalty. So that's a beautiful thing. You can do the homework assignment 10 times if you want to try to attain the highest score, right? All right, class activities will be given every class session. I will have a couple of them for you today. Okay, so just make sure you have something to write on, something to write with, and for today. And again, I want those emailed to me by midnight, the same day of the class session. For instance, any class activities I have you do today, I would like those. I would like you to email those to me by midnight tonight. Okay, and of course, what are you going to put in the subject line? You're going to put math 115 what hybrid 02. Do you agree? Please always proceed your message with that tag. All right, like I said, class activities are only done if you're in attendance. If not, you just miss out on an opportunity. I'll drop 2 lowest class activities for computing final grades. All right, on the activities, I do want you to show some work for your class activity problems. Okay, Canvas obviously is an important exchange hotbed for our course. That's where we're going to exchange documents. Attendance will be taken every class session through the Zoom reporting feature. Ladies and gentlemen, if you log on to Zoom with some sort of strange handle, like without anything to do with like your name, your first and or your last name, if you have a strange handle that you log on to Zoom with, please let me know about it. Otherwise, I will, on all likelihood, be marking you absent. So it's very important. If you don't have any part of your first and or last name for your Zoom handle, it could be a problem taking attendance. So let me know about it. All right. Okay. Missing excessive classes could affect your financial aid if you are receiving that. Office hours are basically going to be virtual. If you need any extra help with anything, just email me and we'll arrange a time and a day to meet. I'll just send you a Zoom link and we'll meet one-on-one, and then I can address your problems, okay? These are important dates. Of course, today is the first day of class. You have until January 19th, which is 3 days, to drop the course with a full refund. And you have up till January 23rd to drop the class with a 50% refund. Okay. last day to audit the class, that is to say that you paid for the course, but you're just gonna sit through and view the material and not receive a grade. To file for an audit status would be, the deadline is March 22nd. Spring break is March 11th through March 17th. And the college is closed, and all satellite campuses are closed also during that week. Last day to drop the course with a W grade is April 26th. So you can go through this entire course pretty much, view the entire course, and then bail out by April 26th with a W grade if you are failing there. If you're on the bubble, you can email me and let me know your concerns, and I can maybe look at your grade and indicate yay or nay as to whether or not you should file for a W grade. But ladies and gentlemen, if you don't withdraw from the course and you're failing the course and you never withdraw from the course, at the end of the semester, I will have no other recourse than to issue you a failing grade. So if you are failing the course miserably, please do withdraw from the course formally. I'm not going to withdraw you from the course. That's something you need to do. Last day of class is May 2nd, and final grades have to be turned in by the 6th day of May, 2024. Okay, if you have any sort of accommodation, ladies and gentlemen, or disability, you can secure the paperwork at the disability office. Here's also a phone number for disability services at Mount Community College. It's a letter that they award you, and you would have to forward that letter to me, and I have to, by law, I have to accommodate you according to the letter, okay? If you want to add anything to that, or maybe clarify those accommodations, you can get in touch with me via email. It will be private, and let me know any specific concerns you have with those accommodations. All right, so I'll keep that all in mind. If you are pregnant, then you also are extended an accommodation for your pregnancy as far as class deadline, due dates are concerned for assignments and stuff like that. So, like I said, just let me know if you have any special accommodation. All the information's right here as far as phone numbers and contacts are concerned. All right, this is the criteria to qualify for an incomplete grade. You can read through the qualifications if you feel like you need an extension on the course to complete it. But again, ladies and gentlemen, I'm usually very reluctant in issuing incomplete grades. That is ultimately up to my discretion whether or not I will ultimately award you an incomplete grade. Bare minimum, you have to satisfy these requirements to even qualify. If you don't even satisfy these requirements, then there's no chance of getting one anyways. Okay. This is the withdrawal policy. School closings, we don't really have to worry about that. This being a virtual course, darn, that takes away the fun of a school closing, huh? But yep, so there it is, ladies and gentlemen. Any questions or concerns about the syllabus here so far? Any questions or concerns?
Any event that we have to meet in person and we have work, and how do we?
Yeah, sometimes a lot of students have wanted me to look at maybe some of their Alex problems, okay? And we'll bring up the Alex website and go in particular into your account. We'll look at the problems that you're struggling with, and we'll try to address them from there. Usually it's Alex work, okay? If there's any work out of the textbook that you would, any problems.
No,
you
I mean, like if we have to meet in person,
Oh,
do we ever have to meet in person, or is it strictly
no,
online?
no. We don't ever have to meet in person, okay?
Okay, okay,
We would make a Zoom appointment, okay, via email,
okay, cool.
and then we'll go.
Okay, I just
Um,
wanted to make sure, so I just would know what
yeah,
days that I
no.
can.
Yeah, like office hours can be done virtually, okay? We don't have to
Okay,
meet in person.
okay.
Okay, now another thing, ladies and gentlemen, there's another couple of other very important things here. If you want free tutoring, the college does offer it at the main campus. in the Gorman building. The Gorman building is the math science building. In room 2106. Okay, that's the free tutorial math empowerment center, or the tutorial center. There is capable tutors available there, and the schedule and the days, I don't know those yet for this semester, but as soon as I get them, I will relay those to you and also post them on Canvas. Okay, now here's
I
a
have one
beautiful.
question really quick. I'm sorry. Do you prefer the Alex book, or would you prefer the hard copy, or it really doesn't matter?
No, that's really up to you, up to your discretion. Some people like to have a hard copy because, you know, I mean, it's easier, I guess, maybe to actually access the pages and all that stuff. And that's understandable. But you don't have to have a hard copy. You can use the e-textbook on Alex for the entire course. Does that make sense? Sir?
Okay. Yep, that does. Thank
That's
you.
really up to you. Yeah. Now, here's another nice thing, ladies. If you frequent this tutorial center, on a frequent basis, maybe like even like maybe one attendance, 1 day a week, let's say, throughout the semester. At the end of the semester, if you present to me or email to me the proof of having frequented this tutorial center on the main campus, all right, that will gain you an extra 1% added on to your overall course grade after all adjustments have been made. Now, that don't sound like much, but I'll tell you what, if you're kind of like on the edge, you know, of a grade category, that might be enough to boost you up into the next grade category. All right. Here's another extra credit opportunity at the end of the semester. At the end of the semester, I will indicate what lecture notes I would like you to email to me as proof of having kept lecture notes throughout the entire semester. I'll email you the specific requirements as to which ones I want you to send me at the end of the semester. If you send me those, ladies and gentlemen, you will also earn an extra 1% extra credit tacked on to your overall grade after all adjustments are made. So look at this. You have an extra potential of plus 2% extra credit added right onto your grade. So like if your grade is like an 86%, after all adjustments have been made. If you get this 2%, I'll bump your grade average up to 88% automatically. And that might be more than enough to propel you into the next higher grade category. So keep that in mind. Now, you can do one of these or you can do both of them. All right, it's up to you. Or you can do none of them. It's extra credit. It's entirely up to you. But those are opportunities to keep in mind. All right, so by having frequented the tutorial center, and what do I mean by frequented? Well, I would say probably at least 1 day a week throughout the semester. What you do is you take a piece of paper in there. You can, you know, indicate the date and time that you're in there and just have a tutor initial next to the date and time. That's all you got to do is keep track. Keep that paper throughout the semester and then email it to me at the end of the semester. If it looks like you frequented this lab, you'll get your 1%. The lecture notes. You know, if you at the end of the semester submit to me exactly what I want you to submit for lecture notes as proof, you'll get 1% added on. So just keep that in mind. That's a wonderful opportunity to boost your overall grade. Okay. All right. Any questions so far here? Okay. Let's see now. All right. Schedule. Wait a minute. Hold on a second. Here we go. Schedule. All right, we don't really have to worry about you know, school closings per se. So it's unlikely that a major changes will have to be made to the schedule. I may from time to time extend some due dates on various things. And if I do so, I will let you know both in class and also by email, and then also make the change on the schedule. But today is the 16th day of January, 2122 is what I hope to get through. And this is basically how it's going to be laid out here. Okay. Notice the first assessment on Alex, which will be a chapter 2 quiz, will be due by midnight, January 28th. And notice the Alex chapter 2 homework from sections 2122, 23, 24 will be due by midnight, January 27th. Okay, all that's going to be done on Alex there. Okay. Is that making sense there? The first Alex exam is going to be due by midnight, February 7th on chapters 2 and 3 material. It's only going to quiz you on, sections that have been covered. If I did not cover a section, then you're not responsible for it. But again, what order should you do things? As far as homework, quizzes, and exams are concerned? Should you take the exams first, then the quizzes, then the homework?
No.
That'd be a terrible way of doing things, ladies and gentlemen. You want to try to optimize your chances of getting the best grade on these things. And since exams are weighted a little bit more heavily, okay, and you only have one take on those as opposed to quizzes and homework, you obviously always want to do the homework first, then the quizzes, and then the exams in that order. Very important. That'll give you the maximum opportunity of getting a good grade on your exam. All right, spring break, notice March 11th, March 17th. The college is closed. We do not meet during that week. And there is no cumulative final exam. Notice the last exam is just on chapter 11 material, 11.1 through 11.7. And that'll be due by midnight, May 5th. Why do I have to have it by midnight, May 5th? Because what's due on May 6th? What do you think's due?
The grades.
The grades. I have to have the course grades in, and they don't give me a break. They want them. They got to have them. And if I'm late, we're all screwed. Okay, so I got to have those grades in, and that's why there's no wiggle room, unfortunately, for the due date of that last exam there. But any questions about this schedule here? Notice I always have the homework due before the quiz. And then the quiz due before the exam. There's a reason for that. Because I want you to work in that order. Homework, quizzes, and exams. All right, any questions about the schedule? There it is. All right. Okay, any other questions before we get started on the syllabus and or schedule or anything else pertaining to Math 115? Math 115. All right, ladies and gentlemen, let's get going then. Section 2.1. Oh, wait a minute. Almost forgot. This is very important. Alex. When you get into Alex, ladies and gentlemen, you'll click off to the left side where it says Alex. This is how you'll go through your one-time registration also. Now, you're not going to see it here because I've already established the course. Okay, I'm the instructor. This is not your view. This is my view. Okay, but I'm going to go to the student view here. They have something here which is called, let's see, I'm going to go to your view. Hold on a second. Let's see. Where's the student view? Am I missing something here? Oh yeah, right here, student view. Okay. This is what you're going to see once you register with Alex here. Now they got this, what is called this initial learning, this initial knowledge check, ladies and gentlemen. The initial knowledge check is not part of your course grade. Okay, you can go through and do it if you want, but you don't have to. You're not going to be graded on it. You're not going to receive any points from it, blah, blah, blah. All right, so you can just skip the initial knowledge check here. Now, there is a brief tutorial as to how to use, like, how to use the palette, the writing palette, and the text palette as to how to answer questions when you do Alex homework, quizzes, and exams, okay? So you can go through and do that. It's called a tooltip tutorial. I would recommend you at least view that, all right? But again, you don't have to do that. And the initial knowledge check, like I said, is you don't have to do that, okay? It's not a requirement. Just skip it, all right? normally there's a button at the bottom where it says skip. You can just click on skip the initial knowledge check, just skip it. Or if it's going to hassle you and they want you to go through every screen or every problem, you can just type in like any bogus entry, like zeros. Just type in zeros for everything, just to skip through it really quick. Okay. But when you get into Alex, when you come into Alex, the most important thing, ladies and gentlemen, is in the upper left corner of the screen here. You see these three horizontal little bars up here? That's what you click on. Because when you click on that, it's going to bring up your access to your e-textbook. Okay, see the ebook there you can use for the semester. And it's also going to have homework assignments and quizzes and exam assignments here off on the left pane here that you'll click on. That's all you have to do when you come into Alex here. So all you do again is you just click on these three little horizontal bars, and that's how you access things that you're required to do from Alex. You don't have to do the initial knowledge check and all that other stuff. Okay. Now there is a tools tutorial again that I would recommend you do go through, because look at it, shows you how to use these various tools as to how you're going to be answering questions on homework, quizzes, and exams. So that is important to go through that little tutorial. But when it comes to the initial knowledge check, just skip out of it, okay? You don't have to do it. Does that make sense? Okay. All right, section 2.1, introduction to basic set theory here. All right. By the time we get done with this section, hopefully we will be able to define a set, write sets three different ways, understand what an empty set is, what is the cardinality of a set, classify sets as being finite or infinite, decide if two sets are equal or equivalent. All right, basically a set is a collection of items or objects, okay? We say a set is well defined if for any given object, we can clearly decide whether or not the object belongs in the set. If we cannot, for any given object, decide if it belongs into a set or it should be excluded from a set, then the set is not well defined. So our sets that we work with in Math 115 are always well-defined sets. Okay? We say that if an object belongs to a set, it is an element or a member of the set. It's an element or a member of the set. One of the three ways of representing sets is called the roster method. The roster method is actually a listing of all the elements of a set that are enclosed within braces, okay, and separated by commas. Now, usually it's not important in what order you list the elements of a set. All right, here's an example. Suppose you want to write the set of months of the year that begin with the letter M. Is this set well defined? Why or why not? Well, how many months begin with the letter M? Anybody?
2,
All right. What are the months?
March and May.
All right, March and May. Okay, is this a well-defined set? The set of the months? In other words, if I give you a month, would you have any difficulty in determining whether that month belongs to or does not belong to the set?
No.
So it's a well-defined set then, correct, by definition. All right. There you go, ladies and gentlemen. A way of representing this set would be to call the set M, the set of all months that begin with the letter M. And notice March and May are the only elements of this set. Notice in the roster method, we use braces. We have an open brace and a closed brace, and these elements are separated by a comma. Okay. All right. The set of natural numbers or counting numbers is defined to be N. Uppercase N represents the set of natural or counting numbers in mathematics. It is a set that consists of 1, 2, 3, 4. What do these little dots mean after the 4?
Continue, etc.
That's right. It's going to go on forever, correct? So is this a finite or infinite set? What do you think?
Infinite.
This would be an infinite set because there's an infinite number of natural numbers or counting numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. You could go on till the end of time or death, whatever grabs you first. Do you agree? All right. That's called a set of natural numbers or counting numbers. All right. These three dots are sometimes called an ellipsis. Anytime you see dots at the end of an element of a set, that indicates that the set goes on forever. It's an infinite set. The set of even natural numbers, denoted as the uppercase letter E, is the set consisting of 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, etc., to infinity. Okay. The set of odd natural numbers, denoted as uppercase O, is 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, 23, 25, 27, etc., to infinity. Just making sense so far here. Notice sets are denoted or named by using uppercase letters. Uppercase letters. Okay. All right. Use the roster method to do the following. Write the set of natural numbers less than 6. Write the set of odd natural numbers greater than 4. And maybe can you think of another way to describe these sets using words? And so, ladies and gentlemen, we arrive at what is called classwork number 1. Now, what I want you to do is take out a piece of paper, and at the top of it, put your name, put Math 115, Math 115, and of course, hybrid what? Hybrid 02 dash HYB02. And I want, you can put today's date on there also. And I want you to put classwork 1. You can just say CW1, classwork number 1. I would like you to do these problems A, B, and C right now. Okay, so I'll give you a couple of minutes to do these problems. See if you can do A, B, and C. All right, classwork 1, we'll call that. So you will email this hopefully to me by midnight tonight. Okay. Okay, so for this classwork 1, they want you to represent these sets using the roster method, which basically uses an open brace and a closed brace, and inside you got your elements that represent the set. So for A, write the set of natural numbers less than 6. So that's going to be a set consisting of what numbers do you think?
1, 2, 3,
1 through
4.
5.
1, 2, 3, 4, 5, correct? All right. And
Yes.
there you go, ladies and gentlemen. So that would be the roster way of representing all natural numbers or counting numbers less than 6. The next one is B, write the set of all odd natural numbers greater than 4. Unlike the first set, which is a finite set, do you agree? The second set is what? Infinite. Because the second set is going to be consisting of 5, 7, 9, 11, 13, 15, 17, 19, 21, 23, etc., all the way to infinity. So that's an infinite set. Now, another way to represent sets is not to necessarily just use the roster method, but you could also use like a word description to describe what the elements of a set would be. And so, like for part C, a little bit more challenging part of this class assignment here, can you think of another way to describe each set in words? Like for like A, can anybody maybe in words describe the set of all natural numbers less than 6?
Numbers smaller than the number 6, maybe. I don't know.
Yeah, I mean, it's kind of weird because the way they're representing the questions, if these are questions in A and B, is they're already kind of describing the sets in words, aren't they? So that doesn't leave much room for, any other way here. So let's see what they got. It says the first set could be described as a set of natural numbers less than or equal to 5, or between 0 and 6.
So less or more than or equal to.
Yeah. Second set could be described as a set of odd natural numbers greater than 3 or greater than or equal to 5. Let's see. Let's see. Okay, I understand the natural number is greater than 3. That makes sense. Oh, wait, a set of odd natural numbers greater than 4. Greater than 4. No, it would have to be greater than or equal to what? 5, correct? I don't know why they got that greater than 3 in there. All right, so that don't make any sense there. Because they have to be greater than what, 4, right? Yeah, so, all right. All right, any questions about this so far, ladies and gentlemen? The roster method for representing sets, pretty straightforward?
Yeah.
Okay, and notice these sets are well defined, correct? In other words, if I give you a number, it's obvious whether the number is or is not going to be in the set. In other words, 8, would 8 be an element of the first set? The answer is, yeah, obviously what? No.
No.
Would 20 be an element of the second set? B?
No.
No,
No.
No.
it's not an odd number. So these are well-defined sets. All right, set notation. Now this little symbol here that looks like a little E here, okay, that's called, this symbol represents is a member or belongs to. Okay, so this symbol is used to show that an object or an element belongs to a set. For example, if A is the set of days of the week, we could write Monday as being an element or being a member of set A. See the notation here? So that symbol means that the Monday belongs to set A, or it is an element of set A, or is a member of set A. That's what that means there. All right, Friday also would be in set A, correct? So this is symbolic notation of shortening things up when it comes to sets. Now, when an object or element does not belong to a set, then we would put a slash through that little symbol. That negates an element belonging to a set. So, for instance, ice cream day is not a day of the week, so therefore ice cream day would not belong to set A, correct? If again, set A is a set of days of the week. So a slash negates things, right? That makes sense there, that symbol? All right, decide whether each statement is true or false. All right, we'll call this class, we can also call this part of classwork 1 here. All right, go ahead and do these, ladies and gentlemen. I'll give you about a minute to do these. This shouldn't take long, okay? Just decide whether each of these statements is true or false. Pretty simple. All right, is A true or false? Is Oregon belong to the set A, where A is a set of states west of the Mississippi?
True.
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 Okay, how about B? True or false? Does 27 belong to this set?
True.
Yeah, it's an odd
True.
number. That'd be true.
Okay.
C, does Z belong to this set? No, wait, the statement is Z does not belong to this set. Is this true or false?
False.
This is false. Z is in that set, okay? So does that make sense here? Pretty simple so far?
Yes.
Okay.
Could you help me? Like number, letter B. What was it? I thought it was like they was doing fours or something.
No, well,
Odd numbers.
let's see here. Well, these are not just odd numbers, it's every other odd number. Do you agree? So maybe we need to think about this a little bit deeper. There's 27 in there. Well, what would be the next odd number? Every other odd number. Notice that's what
31.
this is. So it'd be what, 21 next, right?
Mhm.
Yeah.
And then it'd be what, 25?
Yeah. Okay.
Oh, then it'll be what? 29? Uh-oh. This is not a true statement, is it?
No.
No.
No, it's
Nice
false.
observation. Yeah, see, we were not paying attention close enough. We just assumed they're all odd numbers. All right, so we got into trouble. Ladies and gentlemen, this is a false statement. 27 is not in this set. Okay. 'Cause
Wait,
these
is
are-
it because it's false because it went every other number?
It's every other odd number. That's why. Yeah.
Okay.
It's
I thought
every
it was
other
every
odd number.
four.
Yeah, that's why. Now, if it was all the odd numbers, yeah, 27 would be in that set, correct? But it's
It
every
also
other.
goes- It goes 4 up every number too. So if you just kept counting,
Yep,
Yeah.
it's
would
every
be-
four.
For every four numbers after that, however you want to think about it, okay? But do you agree 27's not in there, is it?
Nope.
All right, so that's a false statement. So just be a little bit careful. Thank you for bringing that to our attention. All right, ladies and gentlemen, there's 3 ways to list sets: roster method, descriptive method, and set builder notation. We've already looked at the roster method. What's this descriptive method? Well, here's an example. Use a descriptive method to describe the set B containing 2, 4, 6, 8, 10, and 12 in 2 different ways. One way to describe this set is to say what? Set B is the set of even what? Natural numbers less than what? Less than 14. Do you agree? Those are even and they are natural numbers and they're all less than 14. Isn't that true? That'd be
Yes.
one way to describe the set. There's many other ways. That's not the only way here. All right. Another way is to say it could be the set of natural numbers between 1 and what? 13. Do you agree? That'd be another way of coining the set. Set of
Yes.
natural numbers between 1 and 13. That are also what? Divisible by what?
2.
2. Yeah. Notice that.
Oh yeah.
Because if you just say all natural numbers between 1 and 13, that would include what? Like 3, 5, do you agree? 7. But to say that they also have to be divisible by what?
2.
Who limits you to saying 2, 4, 6, 8, 10, 12. Does that make sense there? Okay. And can anybody else think of another way maybe to, describe the set? There's a couple of ways.
Less than 13 divisible by 2.
Yeah, you could say, less than 13. All natural numbers less than 13 that are divisible by 2. Exactly. You could coin it that way too. All right. So, some of these questions, there's quite a few acceptable answers. All right. A variable. Usually when you get into a course in elementary algebra, you begin talking about what are called variables. And variables are letters. Usually, the most common variables encountered in early algebra would be like X's and Y's, and maybe like the variable Z. Okay, but any letter could qualify as being a variable in mathematics. And a variable is a letter that can be assigned any numeric value, right? Well, when we describe sets using set builder notation as opposed to roster and the descriptive method, we always need to use a variable. It's part of the requirement for set notation or set builder notation. So let's see how set builder notation, or sometimes it's just called set notation, makes use of the variable. Let's see how that would work out. In other words, if I had a set consisting of 1, 2, 3, 4, 5, 6 here, a way of representing that using set builder notation is to represent it this way. This is called formal set builder notation. And how do we read this notation? How do we read this set here? Well, this is how you read it. We read this as the set of all elements X such that, this vertical bar means the words such that X is a natural number. Notice X must be a natural number because it belongs to the set of natural numbers. And X must also be what?
Less than 7.
Less than 7. Does that make sense? That would be a way of representing this set of numbers here. To say that it's all numbers X such that X has to be a natural number and it has to be less than 7. Do you agree? Does that name this set here?
Yes.
It does. It's a much more compact, a little bit more theoretical way, if you will, of representing that set. Not as obvious as, the roster way, which is this way right here. But nonetheless, when you think about it, it is describing this set precisely. Okay, this is called set builder notation. They always have this vertical bar that separates the variable from the requirements of the variable. Okay, this bar means the words such that. Okay, so again, it's a set of all it's a set of all numbers X such that X must be a natural number and X must be less than 7. That's called set notation or set builder notation. All right, moving on. All right, example 5, writing a set using set builder notation. A, the set R contains the elements of 2, 4, and 6. And how could we use set builder notation? This is not a classwork, ladies and gentlemen. I'm going to pick up the speed a little bit here. We're starting to fight the clock. All right, so we're going to do this kind of as a whole class here. The set R contains the elements 2, 4, and 6. We could obviously, throw braces around this and we would have the roster way of representing the finite set. Do you agree? But how could we use set notation to represent this set? Well, one way is to say R is a set consisting of
X such as X.
That's right. Set of all numbers X such that X must be what? An even. Remember what this was? E here. That was an even natural number, correct? X has to be an even natural number. And X has to
X
be
is less than 7.
less than 7. Do you agree to say that it's the set of all numbers X such that X has to be an even natural number that is less than 7? Do you agree that is describing the set consisting of 2, 4, and 6? Do we understand? Isn't that true?
Yeah.
Okay.
Yeah.
Okay. Well, this is a more compact way of doing so. All right. Now this next one here is how would we, using set notation, describe the set W that contains the elements red, yellow, and blue? Well, some of us may or may not know this. I had to jog my memory the other day. The colors red, yellow, and blue, belong to what are called the primary colors in the world of art. Okay, they're called the primary colors. So a way of describing this set W then, using set notation, is to say that W is the set of all colors X, such that X is a what? It has to
Primary color.
primary color, which would mean red, yellow, and blue. Now, when I give you an Alex assignment, I'm probably not going to give you one like B here because I don't think this is obvious to everybody. I mean, I wouldn't assume that everybody knows this. Okay. I'm going to give you one more obvious like A. All right, so don't worry too much about this B one here. I mean, hey, if you didn't know that, red, yellow, blue are primary colors, I mean, don't feel bad. I mean, I fell into the trap a couple of days ago. I had to refresh my memory as to what primary colors were. So I'm not going to give you one like that on Alex. All right, here we go. Designate the set S with elements 32, 33, 34, 35, et cetera, et cetera. So this is a finite or infinite set. What do you think?
Infinite.
That'd be infinite. Using the roster method, of course, we would just throw what? An open brace and a closed brace around this. Do you agree? And we would have the roster way of doing that. Does that make sense?
Yeah.
The descriptive methods, we have to become a little bit more imaginative. How could we in words describe? What would be one way, and one among many possible ways of describing the set in words? Anybody?
A natural numbers greater than 31.
That's right. That'd be a good way. It's a set of all natural numbers greater than 31. Or you could say the set of all natural numbers greater than or equal to 32. Do you agree? That would work. Let's see what they did. They said it's a set S that is a set of natural numbers greater than 31. There you go. That would work. All right. So there's a lot of latitude in the second answer here. How about set builder notation? How could we describe the set using the more formal set builder notation?
N
What-
equal, X equals, X such that X
Is what kind of
is a
number?
natural number greater than 31.
There you go. It's a set of all numbers X such that X must be a natural number, and it also has to be greater than 31. That would be naming that set. Okay. So do we understand the differences that exist between the roster, the descriptive, and the set builder method way of naming sets? 3 different ways. Okay. All right. Using ellipsis. Ellipsis means that there could be more elements in between 2 elements, or it could be an infinite set. For instance, use the roster method to write the set of all even natural numbers between 99 and 201. Even natural numbers between 99 and 201. Do you agree we'd have to pick up the first even number after 99, which is 100, then 102, 104, 106, 108, 110. But ladies and gentlemen, it's going to take forever to get up to what? 200, isn't it? So why not put little dots in between here? That means there's a continuation of the pattern established by 100, 102, 104, all the way up to 198, and then terminates at 200. So is this an infinite or a finite set?
Finite?
Infinite.
Well, you see the 3 little dots
Infinite.
here, but in this case, the dots are not at the end of a what? End of an element in the set. That means that the set does terminate at 200. So it is a finite set. Little dots mean that the numbers continue to follow the pattern that was laid out between 100 and 104 and between 104 and 198. All right. So that'd be a way of using an ellipsis. Instead of having to write the numbers 104 all the way up to 200, that would take a long time and use a lot of paper. All right, a set that does not have any elements in it is called aptly the empty set or the null set. So an empty set or a null set is a set that does not have any elements in it. Does not contain any elements. The symbols used to represent the null set are a set of empty braces or this circle with a slash through it. That circle with a slash through it also represents the empty set or the null set. So there's 2 different ways of representing a set that has nothing in it. Those are the 2 ways. Right. Which of the following sets are empty? A, the set of woolly mammoth fossils in museums. The set of woolly mammoth fossils in museums. Well, this is kind of a vague one. I probably wouldn't give you one like this on Alex later on, but do we have any woolly mammoths running around, elephants that have long hair on them and tusks?
No.
No.
We used to have those back in the prehistoric days in Michigan running around. Those are all extinct now on planet Earth. So therefore, they might be found what? The remains might be found in museums. Do you agree?
Yeah.
Do you think that this set is empty or not empty to say it's the set of all woolly mammoth fossils in museums?
Mm.
Not empty.
Yeah, it's not empty. Since there are museums that do contain their fossils, we have one right at Bach Community College in the first floor of the Gorman Building. There's a woolly mammoth tusks that were unearthed in Michigan by one of my former professors. If you ever get a chance to walk through that geology museum on the first floor of the Gorman Building, please do take the time. It's a wonderful collection of minerals and fossils from around the world. Really amazing. All right, ladies and gentlemen, the set of all X, such an X is a living woolly mammoth. Is this an empty set? X is a living woolly mammoth. Do you think this?
It's
No,
empty.
it's
Is it
empty. It's
empty?
empty.
Yeah.
There
No.
are
Yes.
none. There are none living woolly mammoths running around, so it's an empty set. This one is tricky. C, be careful. Is this an empty set?
Yes.
No.
All right, if you said no, you're correct. Ladies and gentlemen, notice we have braces, but inside the braces, let me ask you this question. Do you see anything inside the braces? Anything?
The
Yes.
empty set symbol.
Ah, but there is something inside the braces, though. Do you agree?
Right.
So
I
it
agree.
is.
Technically, it's not empty. Yeah,
Is
that's
it
a
an
tricky.
empty set?
Yeah, I know. It's technically, though, there is something inside the braces. It's called the empty set. Technically,
Right, okay.
it's not empty. That's a tricky question. All right, how about
They're
D?
both empty sets, but it's an empty set inside of an empty
Yeah, that's
set.
right. You got something inside the braces. That's why the braces are not empty. Okay, that's why, that's not considered to be an empty set. How about
D
D?
would be empty.
That's
Because there are
correct.
no natural numbers between 1 and 2.
That's correct. There's a whole bunch of decimals and fractions, though. In fact, there's an infinite number of decimals and fractions. Do you agree between 1 and 2? But there's no natural numbers. You are correct. D would be an empty set. All right.
We aren't writing these down, right? We're just going through them.
No, we're just kind of going through these. This is not a classwork, okay? And you
Okay.
have this PowerPoint presentation on Canvas, so you can go back through it. And obviously, you're going to have this recorded. You can listen to it, all that. So it's all here. So what is the cardinality of a set? The cardinal number of a set is the number of elements that are in a set. For example, for a set A, the symbol for the cardinality is this little n here, and then you got inside parentheses the name of set A. That n represents the number of elements that are in set A. That's a way of representing the cardinality of set A, is to represent it using this notation here. That is to be interpreted as the number of elements that belong to set A. That's also called the cardinality of the set A. Okay? Or they say N of A, number of elements in A. Examples, what would be the cardinality of set R? How many elements are in set R?
5.
5.
There's 5. So we would say N of what? R is equal to what?
5.
5
5.
elements in set R. True? That's the cardinality of set R. That's all there is to it. Okay. Nothing more than that to that. So what's the cardinality of set A?
A equals
N of A, right? N of A
N of A
Equals 6.
equals 6.
equals 6. That's right. What's the cardinality of set B?
NB.
Well, set B is a set of all numbers X such that X is a natural number and X is less than 16. So how many natural numbers are less than 16?
15.
There's 15, 1 through 15. Do you agree?
Yes.
Cardinality of set B would be 15 elements in set B. How about the C? What's the cardinality of set C here? What's N of C? How many elements are in set C?
16.
No. How many elements are in set C?
One.
There's only
2.
one element. There's only one element in set C. It's the number what? The natural number
16.
There's
Mhm.
the
1.
cardinality would be 1. Cardinality. Yeah, don't confuse the cardinality with what the actual number is. All right. Okay. There's only one element in set C. That's the natural number 16. What's the cardinality of this set?
Nothing.
We would say
Empty.
0. Because the empty set has no elements. Do you agree? 0 elements in it. True?
True.
All right, we good on cardinality?
Yeah.
Okay. That's all there is to cardinality. All right, I've been alluding to finite infinite sets here up to this point. How about the set consisting of P, Q, R, and S? Is that finite or infinite?
Finite.
That's finite. How about the set 10, 20, 30, dot,
Infinite.
dot, that's infinite. Okay. I
Yeah.
think we're pretty clear on what it means for a set to be finite versus infinite. Okay. Set A here, finite or infinite? The set of all numbers x, such that x is a natural number and x is less than 100. Would that be finite or infinite?
That'd be finite.
Finite, 1 through 99. Do you agree?
Yeah.
B, set R is a set of letters used to make Roman numerals. Finite or infinite?
Infinite.
Finite.
I don't know. I don't really use Roman numerals that much here. They're calling it finite. The letters used are C, D, I, L, M, V, and X. So it is finite. I learned something right now. Did you know that, ladies and gentlemen? There's a finite number of letters in the Roman numeral set. Huh.
No.
Yeah, I mean, I'm not going to
I
give you.
don't know how, but I did.
Yeah, hey, that's more power to you. I'm not going to give you, questions like this that are vague. Okay, this is kind of vague. I mean, I didn't know that. All right, I'm not going to give you a question like that. I'm going to give you one that's more obvious. Like C, is that finite or infinite?
Infinite.
That's it.
Infinite.
That's infinite. That's obviously infinite. D, the set M is a set of people who went to your elementary school. Finite or infinite?
Infinite.
Infinite. Because there's a lot of people.
Finite.
Yeah, but it's not everybody on the
It's
planet.
not so
you
many
agree?
years. Just
Yeah.
Yeah, okay.
Yeah,
Yeah.
it's finite. I mean, only so many people went to my elementary school.
Elementary school. Okay.
That'd be finite. E, set S is a set of
Infinite.
songs that can be written. Set of songs that can be written.
Infinite.
Well,
Yeah.
geez, I mean, new songs are being written all the time. Do you agree? That seems like
Infinite.
the infinite.
Yeah.
I'd say infinite. Yeah, infinite. Okay. But again, I'll give you ones that are obvious. I'm not going to give you ones that are gray areas. Now, this one is tricky. Two sets A and B are equal, written A equals B, if they have exactly the same members or elements. Two finite sets A and B are said to be equivalent, written A, notice the equivalent symbol. It's an equal sign with a little tilde above it. That's called a tilde symbol above the equal sign. Two sets are equivalent if they have the same number of elements. In other words, their cardinalities are the same. So what's the difference between sets being equal versus being equivalent? If a set is equivalent, does it necessarily mean it has to be equal?
They might have the same amount of numbers in a set.
You have to be equivalent. Two sets have to have the same number of elements inside. It's not saying that the elements have to be identically the same elements, though. Do you agree?
I agree.
So
I
they
agree.
for sets to be equal, they literally have to be mirror images of each other, both in cardinality and the actual members or elements have to be identical too. But to be equivalent, only the cardinality of sets have to be equivalent. That's not to say that the elements have to be the same. So be careful on that one there. So in other words, in A, are these sets equal or equivalent or neither?
Equal.
Equivalent.
Yeah, both sets have 4 elements in them. Do you agree the cardinalities are 4?
Yes.
So they would be equivalent, but they would not be equal. Why would they not be equal? Because
Different letters, different elements inside.
that's right. The letters are not the same between both sets. So we would use this symbolism right here. A little tilde symbol and then the equal sign. This means equivalent. That's called the equivalent symbol. Not the equal sign, just the equal sign with a little tilde symbol above it. That's equivalent. How about B? Equivalent or
Equal.
or neither?
Equivalent.
These are equivalent. They both have the same cardinality and the elements inside both sets are identical. These are equal sets. How about number 3? Careful here.
Neither.
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 Yeah, look at this is not the numbers 2, 1, and 3. No, this is the number 213. versus the numbers 2, 1, and 3. The cardinality of the first set is 1. The cardinality of the second set is 3. These are neither equivalent or equal. How about D?
Equivalent.
Okay, they're equivalent. That's
E-
correct. They both have 4 elements in them, right? But the elements are not identical. So we cannot say they're equal, but we can say they're what?
Equivalent.
Equivalent. How about E? Even natural numbers less than 10 versus 2, 4, 6, 8.
That'd be equal.
Equivalent. Equal, yeah, they're equal.
That's
Mhm.
right. That's right. They would be equal to each other. Not only is cardinality the same, but the elements are also the same. All right. So equivalency versus equal. There is a difference. One-to-one correspondence. This is not really a big thing, but two sets have a one-to-one correspondence of elements if each element in the first set can be paired with exactly one element in the second set. What is all that saying here? Well, you know, we would say the set consisting of 8, 16, 24, and 32, okay, has a one-to-one correspondence with the set consisting of S, T, U, and V. Why? Because every element in the first set could be matched with exactly one element in the what? The second set. Everybody see that there? We call that a
Yes.
one-to-one correspondence, okay? That's not really a big thing for this course. It comes in handy in a course in algebra when you start talking about a one-to-one function, but we're not dealing with that here, so that's not a big thing there, okay? All right, that's the end of that there. What time is it? 1:55. Okay. See, we're fighting the clock today because I had to go through the syllabus and all that other stuff. That's why I don't really care for first days, because it really burns a lot of time, valuable time. All right. Okay. Section 2.2. Hey, this is a quicker section. All right. We don't have as many slides in this one. Subsets and set operations. This is a little bit more involved, but not as many slides. When we get done, hopefully we'll have a better understanding as to how to define the complement of a set, find all subsets of a set, use subset notation, find the number of subsets that a set has, and find the intersection or the union or the difference of sets. There's a lot of things going on here. I hope I have time. Lisa, when we talk about a set, automatically there exists, or we cannot exclude something that comes into the conversation called a universal set. A universal set for a given situation symbolized by U for the word universal, is a set of all objects that are reasonable to consider in that situation. For instance, let me give you an example. Suppose that I go to a university campus and I'm only interested in all English majors on that campus. Only students that are majoring in English. I could form a set of all those students. Do you agree? All right. By the way, would that be a finite or infinite set to say I have a set of all English majors for a particular university campus? What do you think?
Finite.
That's finite. Now, suppose there's a bigger set that my small set of English majors falls into or belongs to. This would be called the universal set. Does anybody have an idea as to what the universal set would and should probably be defined for my situation of my set of only English majors? What would be an appropriate way to define a universal set for this situation? Anybody? If I'm just concerned about English majors, what's a bigger set of all English of just including only English majors? What would be a bigger set that would include this set?
Would it be the students on campus?
That's right. You could say that. Let the universal set be that all students that attend this particular university. That would be the universal set. My set is just a small subset, if you will, correct? Only consisting of a particular group of students, which is the group who are English majors. Okay. So yeah, universal sets always exist for any set that you talk about. And once we define a universal set in a given situation, we are restricted to considering only elements from that set, though. So in other words, if I define the universal set to be all students that attend, let's say, the University of Michigan Flint campus, Okay, if I define my universal set to be that set there, then ladies and gentlemen, could I talk about a set from my universal set as being the set consisting of all postal people that work in the city of Flint?
Yes.
Again, my universal set is a set of all students that attend University of Michigan Flint campus. Then could I talk about a set that's related to my universal set that consists of all what, just postal workers that work within the city of Flint? Does that have any relevance here?
No,
No.
None whatsoever. Do you agree?
Agree.
Well, wait a
agreed.
minute. Wait a minute. Wait a minute. Wait a minute. We're assuming these postal workers are not also students at the U of M Flint. Do you agree? You got to be careful of that, ladies and gentlemen. But okay, if U is the universal set of all students who attend the University of Michigan Flint campus, and I'm talking about a set of all aliens that live on planet Mars. Is that an appropriate set to be talking about in relation to my universal set?
No,
No.
None whatsoever. No relationship. Okay. All right. Venn diagrams are a nice pictorial way of representing sets. And we're going to be looking at several of these Venn diagrams here. Notice we have this box, and inside this box, it is called the universal set of elements. Nested deeper inside the set of box, we have a red circle. It is defined to be some set called A, okay? So notice the elements that are in set A are the natural numbers of 2, 4, 6, and 8. Notice, ladies and gentlemen, 2, 4, 6, and 8 also belong to the universal set. But let me ask you this question. Do you think the natural numbers 1, 5, 3, and 7 belong to set A?
No.
no,
No. Okay. So do we understand this picture, what it's saying here so far? Okay. Universal set is all the numbers that are included inside the box. Set A only includes the elements that are inside this red circle. That's it. Called a Venn diagram.
Can it be different? Like what is set? You said set, that's set A. Can it be two different sets in the universal diagram?
Oh,
Or
heck
the
yeah.
Venn
Yeah,
diagram?
you can have a lot of subsets within a universal set. Okay.
Okay.
We'll get to that. All right, what's the complement of a set A? A complement of a set A denoted by putting this little prime symbol. You see that little symbol there? That's called the prime symbol. And you know how you read this? You read this as A prime. A prime. Ladies and gentlemen, A prime is the symbol used to represent the complement of set A. These sets are complements of each other. What is a complement of a set? Well, the complement of a set A, denoted as A prime, is the set of elements in the universal set that are not in set A. Okay. For instance, the complement of set A, denoted as A prime, is the set of all elements X such that X belongs to the universal set. The element has to be in the universal set, but it cannot be in what set?
A,
It cannot be in set A. This is the definition of a complement of set A. It's the set of all elements that belong to the universal set, but are not in what? Set A.
set A,
Not in set A. That's right. Okay, let's back up here. Let me look at this one here. All right, what would be the complement of set A, denoted as set A prime? What elements would be in my complement of set A? What are all the elements that are in the universal set that are not in set A?
5, 3, 1, and 7.
Yeah,
1, 3, 5, and
1,
5, and
3,
7.
5, 7.
There you go. You are looking at the complement of set A there. You see that? It's all the elements that are in the universal set that are not in set A. Okay, that's the complement. That's all there is to the complement. Okay. All right. Now, so does this make sense, ladies and gentlemen? That the complement of set A would be all the elements in the universal set, that are not what? In set A?
in set A,
Not in set A, but in the universal set, correct? You're
Correct.
looking at the complementary set of set A. All right, pictorially, that's what you're looking at. All right, so if the universal set consists of V, W, X, Y, and Z, let set A consist of the elements W, Y, and Z. What would be the complement of set A?
B and X.
It would be all the elements in the universal set that are not in set what? A, correct?
A.
So I have
Correct.
a question. I have a question. Would V be in the complement of set A?
Yes.
Yes, because it's in the universal set, and yet it's not in set A. Would W be in the complement of set A?
No.
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 No, because it's
No.
in set A. Would X be in the complement of set A?
Yes.
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 Yes, because X is in the universal set, but it's not in set A. Would Y be in the the complement of set A?
No.
No.
No, because it's in set A. Would Z be in the complement of set A?
No.
No.
You got your answer. This is the complement of set A. That making sense there? Just V and X, that's it. All right, how could we represent all this, by building a Venn diagram for this situation? Well, they don't do that. So maybe I could do that. If I could go back. Okay, so like for A here, we got our universal set, right? Denoted as U. Then we got our set A here, right? Maybe a circle here. There's set A. And we got Y, W, Y, and what? Z, right? And outside of set A would be the what? The complement of
X.
set A.
V and X.
And what was it? V and
V and X.
V and X, right? V and X are in the complement of set A. All right, is that making sense there? That would be a Venn diagrammatically way of representing that there. All right. All right, what is the complement of the universal set? Now, this is a tricky question. What is the complement of the universal set for a given situation? Careful on this one. If you got a universal set here, remember by definition, the complement of the universal set would be all elements that are in the universal set that are not in the universal set. Listen to what I said very closely. The complement of the universal set is a set consisting of all elements that are in the universal set that are not in set U, not in the universal set. Do there exist any elements that satisfy that? The complement of the universal set is a set of all elements that are not in the universal set. Okay, excuse me. The complement of the universal set is a set of all elements that are in the universal set that are not in the universal set. Does that make sense, what I just said?
No.
Sounds confusing.
Sounds very confusing. In fact, it's impossible. How can you have an element that's in the universal set and at the same time not be in the universal set? Is that possible?
Right. Not possible.
It's not even possible. How can you have an element that's in the universal set and at the same time cannot be in the universal set? The answer is there can't be. So, ladies and gentlemen, the complement of the universal set is always the what set? It's always the empty what?
The empty set.
That's right. So the complement of the universal set is always the what? The empty set. You can denote it this way. Or what's another way of denoting it?
With
Zero
the O with the
line.
line through it.
That's right. Okay, either way. The complement of the universal set is always the empty set, always. All right. Subsets. If every element of a set A is also an element of a set B, then we say A is a subset of B. The symbol, this is a symbol to represent subset. So this notation is saying that set A is a what?
A subset
Subset of set B. That's saying that every element that's in set A is also in set what?
B.
B. Every element that's in set A is also in set B. That's what that notation's saying. Now, every set is a subset of itself. Do you agree? Isn't that true?
Yeah.
Because every element in set A is in set A, correct? That's obvious. So every set is a subset of itself. Now, here's an interesting one. The empty set is the subset of every set. So the empty set has no elements in it, correct? Then for any set A, you can't find an element of the empty set that is not in what? Set A. That's a little bit tricky, isn't it? That's
Yeah.
one we just have to kind of ponder for a couple of minutes, correct?
I don't get it.
That's a little weird here. Okay.
Me
So we say the empty set is a subset of set A because there is no element in the empty set that is not in set A. For instance, suppose set A consists of 1, 2, and 3. Question. Is there any element in my empty set that is not in this set A?
Yes.
Yes,
What is that element?
nothing. 0.
1, 2, and 3.
But wait a minute, there's no elements in here though. There's no elements in the empty set.
So it's missing 1, 2, 3.
So ladies and gentlemen, there is no element in the empty set that you can say does not belong to what set A. Because you cannot say that, you technically would have to say then that the empty set is what? Technically a subset of the set consisting of 1, 2, and 3. Tell you what, we're really burning the clock today. I'm going to let you ponder that. Just think about it, ladies. That's pretty deep, okay? But just remember, the empty set's always a subset of any set, okay? Always. All right. Now, suppose I have set A that consists of, how many elements are in set A?
2.
too.
So the cardinality of set A is 2, correct? It consists of the elements, which is the word cold and the word flu. All right. How appropriate for this time of the year. What would be all the subsets of set A? Well, one subset of set A is what? Set A itself. Do you agree?
Mm-hmm.
That makes sense? Because every element in set A is in set A. Do you agree, ladies and gentlemen, that this set consisting of only the element cold is a subset of set A? Because everything in the set consisting of cold, which is cold, is also in what set A?
True.
Isn't flu also in set A?
Yes.
So the set consisting of only the word flu would be a subset of set A. And here we go. Technically, what's always a subset of any set? Just try to remember this. It's always the what?
Empty.
I know, it seems a little weird, but it is the empty set, okay? So how many subsets does this set have? It has
4.
4 subsets, okay? We're on to something very interesting here. All right, don't tune me out yet. We're coming up to something very interesting. Now, as it says, if a set A is a subset of set B and is not equal to B, wait a minute, what does that mean? If set A is a subset of set B, that means everything inside set A is what? In set B, do you agree? But what does it mean for set A to be not equal to set B? What is that saying? What does it mean to say that set A is not equal to set B?
Set A may have more elements inside than B and make it not equal.
No, A would not have more elements inside, but what?
B would.
B
may
could have
have.
more elements. You're right. Yeah, you're correct. So the cardinality of these sets may not be the same. Do you agree?
Agree.
I
All right.
agree.
Now, ladies and gentlemen, look at if every element in set A is in set B, and yet these sets are not equal to each other. That means that the number of elements in set A is not equal to the number of elements in set B. If that's the case, we would say A is not just a subset of set B, but it's a special type of subset of set B. It's called a proper subset of B. So to be a proper subset of set B, set A has to have fewer number of what? Elements than set B. Does that make sense?
Yes.
Its cardinality would have to be less than the cardinality of set B to be a proper subset. So just remember, for set A to be a proper subset of set B, the cardinality of set A must be less than the cardinality of what?
Set B.
That's correct. And yet every element in A must be what? In B, correct? In other words, this must be true. Isn't this saying the same thing that A is a proper subset of set B? To say A is not equal to B means that what? The cardinalities are not the same, right? Means this. And yet this is saying that every element in A is in what? B. To collectively, these two statements are saying A must be what kind of a subset? It must be
Proper.
it must be a proper subset. All right.
Does that mean their cardinality is the same too?
No, not the same. No, if A is a proper subset of B, the cardinality cannot be the same because the sets cannot be equal to each other. Okay. But everything in A must be in B, though. Okay, that is a requirement. I know it seems like sometimes we're splitting hairs with some of these things here. Ladies and gentlemen, check this Venn diagram out here. The blue circle is entirely inside the red one. And there's an element inside the red circle that is not in the blue circle. In this case, the universal set would be the set consisting of what elements? The universal set. 1,
1,
1
2,
through 5.
3, 4, 5. Okay. A is a set consisting of what elements?
1
the
through
odd
5.
numbers,
1, 3,
1, 3, and
through
5.
Yep. B is a set consisting of what numbers?
1 and
1 and
3.
3.
1 and 3. Okay. So I have a question for you. Is set B a subset or a proper subset of set A?
Proper.
Subset. A proper subset.
It's a proper
Because it got-
subset. That's right. So you would say B is a what? Proper subset of set what? A. That's to say that every element in B is in A, and yet
Correct.
what? B is not what? Equal
Equal
to set
to-
A. True?
Yeah. True.
See that there? Okay. So just a lot of terms to kind of think about here. I know it seems like a lot. All right, ladies and gentlemen, suppose we have a set consisting of 3 elements: marketing, English, and psychology. Find all the proper subsets, Notice they want the proper subsets. What is the one set we would have to now exclude if we're talking about strictly proper subsets?
Marketing and
We would have to
Psychology.
exclude the what? We would have to exclude the set itself. Do you agree?
Oh, true. Yeah.
Yeah, because the set itself would be what? Equal to itself. Isn't that true? We're
Correct.
only concerned with proper subsets now. So in naming proper subsets, we cannot name the actual set itself now. Must be a proper subset. We can name these sets here, though. Sets consisting of marketing, English, marketing, psychology, English,
What
psychology,
about the last one?
psychology, and the empty set. The empty set, ladies and gentlemen, is not equal
It's
to
not
the
a proper
original set.
set.
Yeah, it's a subset of this set, but it's not equal to the original set. Do you agree? Do you agree the empty set is not equal to the original set?
I thought it was always equal to the original set. I don't know.
No. To be equal, its cardinality has to be the same, and also the elements have to be identical. Right? Obviously, the cardinality of the empty set is 0, and the cardinality of the original set is 3. So they're not equal to each other. But the empty set is always a subset.
So you wouldn't eliminate all of those because you eliminated the set up there?
Well, to be a
But they
proper
also-
subset, just remember, to be a proper subset, the subset cannot be equal to the original set. And that's why we have to eliminate only the set that is what? The original set, correct?
Right.
Because the original set
So
is
I got-
equal to itself.
So for the last one, that is always a proper subset.
That's
It's
right.
never equal to the
You
set.
are correct. The empty set is always a
Okay.
proper subset of any set, okay?
Okay, always. Okay, that's what I was confused when I thought it was always equal to the just the set, but it's always equal to the proper subset.
Yeah, it's a proper subset of a set, as long as a set has a what? Cardinality of at least 1, correct? How about a subset compared to itself?
That'd be equal.
Is a subset, excuse me, is the empty set a proper or a subset? Or just a subset of itself? What do you think? Are these sets equal to each other?
Yeah.
They are. They're equal to each other. So the subset itself, technically, ladies and gentlemen, is not a proper subset, what? Of itself. Do you agree? It is a subset of itself, but it's not a proper subset of itself. All right, if you want to split here is with the empty set again. All right. Just remember, the empty set is a subset, a proper subset of all sets, unless it's the empty set itself.
So what's the difference between a proper subset and a set? I mean, a subset.
A proper subset is not equal to the set, okay? A subset could be equal to the actual set.
Wait, so the two empty boxes that you just did, that was a proper subset?
Yeah, because the empty set is not a proper subset of itself. It's just a subset of itself.
But they was equal though.
Yeah, that's why it's just a subset. Because to be a proper subset, the sets cannot be what equal to each other, correct?
Right. All right.
Remember that to be a proper subset, the sets cannot be what equal to each other.
Yeah. Okay.
All right, so how about A, true or
All right,
false
speaker.
here? True or false, A, set consisting of 1, 3, and 5. Is that a proper subset or just a subset of the set consisting of 1, 3, 5, 7?
That's a proper subset.
All right, so this would be what? A proper subset. Do you agree? Because the set consisting of 1, 3, 5 is not equal to the set consisting of 1, 3, 5, 7. So is this a true or false statement here?
True. No, it's false.
False. Proper subset does not have the equal sign underneath it. Do you agree? It's just this. Remember that? That's it. Okay. How about B? True or false statement?
False.
True.
False.
Well,
True.
this
False.
is saying this set AB consists
But
is a
they
proper
can't be-
subset of AB. But to be a proper
That's-
subset, the sets cannot be equal to each other.
Equal,
Are these sets
right.
equal to each other?
No.
Yeah, that's it.
Are these
So
sets
that's
equal to
false.
each other? Yeah, they are equal to each other. So this
Yeah,
is the
so it's
what?
false.
The false statement.
False. Okay.
What should they have underneath here to be a true statement? They should have what? They should have the line. You agree?
So the line means proper or no? Not proper.
Proper and a subset, correct? Meaning that it could also be equal to the set, right? You think of it that way, like the equal sign. How about C here? The set of all numbers X, such that X belongs to the set of what? Even natural numbers, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, etc. And X has to be greater than 10. So that would be what set? 12, 14, 16, 18, 20, 22, 24. Would that set be a proper subset of the set of natural numbers?
Yes.
Yes.
That's true. That's true. Because this first set consisting of 12, 14, 16, 18, 20 will never be equal to the set of what? Natural numbers, right? Which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, all the way on up the ladder. Right? So it is a proper subset. That is a true statement there. That's a true statement. What do you think about D? True or false?
True.
It's true.
They're not equal to each other.
Well,
Well, they the
right.
same, but
It's-
they switch
It's
around.
not a proper subset. Do you agree? Yeah, because
Yeah.
these sets are what? Equal to each other, aren't they? That's why it's not a proper subset. So they got the slash through the proper subset symbol. So that's true right there. Okay. All right, ladies and gentlemen, let's see where we are here. Because the clock is killing us. Let's see. All right, hold on a second. Okay. We're running a little on the clock here, as usual here. I'll let you look at those other ones there. And they do have the solutions too, so if you get snagged. All right, now this is interesting, ladies. This is a fact here. If a finite set has n elements, notice it has to be a finite set, has n elements in it, so its cardinality is n. Then the set has 2 to the nth power subsets and 2 to the n power minus 1 proper subsets. That's always true. So look at this. If a set, let's say a set has 1 element in it. I'll even create a set. Suppose a set consists of just the letter A. All right, so ladies and gentlemen, how many subsets are there to this set consisting of just A? Well, there's the set what? Whoops, I'm sorry, hold on a second. If I have a set consisting of 1 element A, okay, how many subsets are there to the set that consists of A? Notice I said subset, I didn't say proper subset. So you could have the actual set itself, correct?
Right.
And you can also have one other set, always understood. Empty set, true?
Mhm.
Now look at how many elements are in this set. What's the cardinality of set? 1, right? The cardinality is 1. What's 2 to the first power? 2 raised to the first power.
2.
That's why this set has 2 what? Subsets. You see that there? If a set has 2 elements in it, you know how many subsets it's going to have? 2 raised to the second power, or 4 subsets. If a set has 3 elements in it, you know how many subsets it's going to have? 2 to the third power. 2 times 2 times 2.
8.
Which is 8 what? 8 subsets. That's always true. Always true. Now, why does the number of proper subsets always subtract off 1? Why? Anybody? Why must we subtract off 1 important set? And what set would that be if they are to
The
be
main
proper
set.
subsets? That's right. To be a proper subset, we cannot include the set itself. Do you agree?
Why is that?
Well, because remember, the sets cannot be equal to each other to be a
Right.
proper subset. Remember that? So, ladies and gentlemen, look at it. If I have a set consisting of 1 element A in here, how many proper subsets would it have? Which set do I have to cross out down here if it's to be a proper subset of this?
That
The set itself. Do you agree? You got to cross the set itself out, because the set itself out is what? The set itself is equal to the original set. Isn't that true?
right.
I just want proper subsets. And so that's why to compute the number of proper subsets that a set has, you always have to subtract 1 from 2 raised to the cardinality of the set. In other words, if a set has 2 elements in it, or excuse me, 1 element in it, how many proper subsets will it have?
3. No, 1.
Yeah, it's going to have 2 to the first power minus 1, which is to say 2 minus 1, which is to say what?
1.
Only 1 proper subset. If a set has 2 elements in it, how many proper subsets is it going to have? 2 to the second
3.
power minus 1, which is to say 2 squared, 2 times 2 is 4, and 4 minus 1 is what? It would only
3.
have 3 proper subsets. Do you agree? If a set has 3 elements in it, how many proper subsets is it going to have? It's going to have 2 to the third power minus
7.
what? 1, which is 8 minus 1, or 7 proper subsets. Okay, always true. So that's pretty neat to know that. I mean, that comes in handy at times, just to know how many proper subsets or subsets that a set could have. So for A here, son of a gun, is it 227 already? I was
Yeah.
having fun here. All right. I won't get to the difference between sets here, but I'll just leave you with this. How many subsets would this set have here? Ace, king, jack, 10, and 9.
8.
How many elements are in this
Oh,
set? 1,
there's
2,
6.
3, 4, 5, 6. So how
6
many
and 6 is
subsets is this going to have?
36.
It's going to have 2 to the 6th power subsets, which is 2 times 2 times 2,
12.
2, times 2 times 2 times 1, 2, 3, 1, 2, 3. No, you got to multiply this all out. Don't add, multiply. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, 32 times 2 is, ladies and gentlemen, they're going to be 64 subsets for a set that has 6 elements in it. And we wouldn't want to sit here and enumerate all those. How many proper subsets would it have? We're gonna have to subtract off
Oh.
one set. What's that one
63.
set? That's right. It's only gonna have 63 proper subsets because we have to subtract off the set itself. Do you agree? Because the set itself is no longer a proper subset of itself. Isn't that true?
Because it's not equal.
No, because it's equal to itself.
Oh,
That's why it's not a proper subset. Okay?
So anytime it's a proper subset, you
It
minus,
cannot be equal to the original set. That's right.
right, and you minus one though.
That's why I always minus one. You have to enumerate the number of proper subsets. Okay? All right, I'm sorry I went over time here, ladies and gentlemen. Like I said, the syllabus and schedule went over all that, killed all the time. But hey, I got through a lot of this. I'll have to finish up with the last slide here today. If you could just email me that first classwork by midnight, that'll be great. You'll get your credit for the classwork for the day. I'm
Is it
gonna
in
also.
Canvas?
What's that?
The first classwork is in Canvas.
No, the first classwork we did in class. It was a couple of PowerPoint slides back, where I wanted you to just do a couple of those problems there. Were you here?
Yeah,
Well-
I think I got it. I did it.
All right. I will also open up section 2.1 and 2.2 homework on Canvas. You can get started with that as soon as you want to. As long as you get plugged into Alex, ladies and gentlemen, you're good to go. And just, you know, the due date's on the schedule again. So when is that chapter 2 homework due? Well, that's not due until what? Midnight, January 27th. That's when the chapter 2 Alex homework is due, but I will open up 2.1, 2.2. All right. You have a good day. Hopefully see you in a couple of days. I'll stay on the line for a couple minutes if you have any questions or concerns. All right, take care.
Have a good day.
See you.
Have a good day.